Welcome to the STS-78 post-launch press conference, and we have with us today Lauren Shriver, Manager of Launch Integration for the Space Shuttle Program, and Jim Harrington, KSC Launch Director. And we'll start with a statement from Mr. Shriver.
Good morning, afternoon. We're extremely pleased that you could make it today, and we are also extremely pleased, of course, to have been able to complete the countdown on Columbia and launch STS-78 on into orbit to start into over 2 weeks worth of life sciences and microgravity sciences. We're extremely proud to have those guys up there going to work, and perhaps Jim will have some details on the countdown. Once we got into the countdown, things went extremely well. We had a few things resisting picking up the count, and some last-minute work to work on during the early part of the count to get things in order to finish the count. But those were accomplished due, as always, to some very heroic efforts on the part of an outstanding launch team here at Kennedy. They worked the problems and got the job done, and got backed out of the vehicle so that we could complete stowing the mid-deck experiments and complete the MVAC into the module pretty much on time and as scheduled. Once we got that done, as I mentioned, the countdown went very well. We did do our usual race with the weather again today, and the weather folks both here locally and in Houston started off early this morning with a fairly good picture, but the night was very clear, of course, and what that meant when the sun came up was that it heated up real quickly, and so we got an earlier onset of the clouds that you see out there now. But we still would have been just fine at an RTLS time point, by at least from my vantage point looking out the window. We had a couple of things during ascent that maybe I'll just go ahead and mention them now, and I'm sure you'll have questions as we go along. You probably heard the discussion with the water spray boiler number 3, which turns out to be working okay on both controllers, so really is not a problem at this point. We also had an indication of an FA1 MDM bite, but it turns out that that is probably due to a transducer or signal conditioner failure in the on the center main engine LH2 liquid hydrogen inlet pressure. That deucer, or that reading, went off scale high, and when the MDM analog to digital converter function saw that, it enunciated that to the ground. The crew does not see that, so that's why we didn't hear anything from them, I believe. And then the other thing that they're continuing to work on is the BFS GPC had a toggling IO term B function, which it toggled low and then back normal or high. And what that means is that the BFS system or computer, if that happens, fails low when it's not supposed to, you're one failure away from an automatic engage of the BFS. It's toggling, or at least it did 2 or 3 times, low, high, and they went ahead and accomplished OHMS 1 with normal configuration. The BFS was still up and running, and they will be working, the flight control team will be working back in Houston to First of all, priority order of business will be to get into a DIPS configuration that allows progression right into the day one activities so that they can get all of the interfaces with Space Lab set up and get on into their work for the first day. And then they'll probably come back and talk through thoroughly what to do with the BFS function, whether or not to change GPCs or not. Turns out that both of those last two things that I described, the sensor malfunction that produced the MDM byte and this BFS IO term B toggle have been seen before in the program, and so they're not new to our flight program. Jim?
Thanks, Lauren. Well, as Lauren said last night when we got in and started the final count, things were a little hectic because for those of you that were here yesterday, you remember the weather that came through this area later on in the afternoon, and in essence what it did is it kept us from rotating the RSS back until about 10:30 last night, which is much later than what we would normally like to have done that, by about 5 hours. So we had a little bit of catching up to do, and the team did an outstanding job of getting caught up with getting the pad cleared and everything else that we have to do to get into tanking. And we started tanking about a half hour later than normal, but things went fine, and we were able to catch up and get caught up by the time that the flight crew was due to come out. We didn't have any particular problems during the countdown, and all went very smooth. The only thing that I might say is that about 8 o'clock or so, 9 o'clock this morning, I've forgotten the exact time, I got a call from Range Weather, and that you may have heard this, one of the field mills that was up north of the pad, up in towards Playlinda Beach, had indicated a charge over it, which turned out to be it was a bad field mill, bad sensor. So we sent some people out there and replaced it, and everything was fine. And it was one of those indications that the range would normally have had to call that as a problem, because of course a field mill is indicative that you've got charged particles around, which is then puts you in a condition of that potentially you could get rocket triggered lightning at liftoff. So that's what we try to avoid. So that field mill was taken care of and went by the wayside. And I might add that the excuse me, the weather guys both here and at JSC did an excellent job of integrating their efforts, because the flight guys were working their end of the mission ops to get ready to lift off on time, because, and as were we down here, because we'd both been advised that because of the heating and the convective temperature that we expected to see, we had a good chance of getting some weather coming in pretty early. So the message was to try and get off in the beginning of the window. Of course, we were able to succeed and do that, but that was a great effort, great integrated effort on both the range weather and SMG out at JSC.
Okay, thanks, Jim. Let's open it up for questions. Let's start here with Irene.
What happens if you have an automatic engage of that BFS?
Okay, if you have an automatic engage, which would have been yet another failure before that happens, but what that does then with with just the BFS GPC thinking it's supposed to take over, and the past GPCs not knowing that, you'd have dual commanders probably for a while until you could react, and the most likely thing would be to take down the BFS GPC to take it to halt. Dual commanders means both the pass set and the BFS think that they're supposed to be controlling the vehicles.
And what's the upshot of all of the technical problems, just that you might have to do, in worst case, swap out a computer?
Well, the flight team is going to be doing an awful lot of thinking and data review obviously they'll look at as much data as they can get their hands on over the next couple of days and decide what to do with the BFS, and it may depend on what signature they see. When it happened before, I mentioned it had happened before. I think it was way back on 32, STS-32, and that incident was in deorbit prep, and we were already in Ops 3, and they got toggling on the bit. Rather than delay reentry, what they did was move the BFS function into another GPC. I think it was number 2, and they did declare that BFS that GPC no go for the uncertainty involved, and then re-entered on a pass set that had 3 computers in it instead of the normal 4. And that's an option. That's one option. But as I say, the data review will tell the folks what's the best course of action, and that's going to be stretching over the next few days.
Okay, Mark, right here.
Thanks, Mark Harrow from the Houston Chronicle. Just to follow up on that, if you had to exchange a computer, and I don't know whether I'm not guessing that that's involved in this, but do you have a spare aboard? I'm not really sure I understand if there is any concern really at all if you have the right software doing the right thing right now, and what sort of the worst case would be. And this isn't some sort of a mission endurance or mission length issue, is it? I mean, this doesn't cause you to shorten the mission at any.
Right now, I don't know of any reason why we would. Don't think that's in the plan at all. As I say, there'll be a lot of data review going on. Currently, there's nothing wrong with the software being used at all. As you know, once ASCENT is done and we get into Ops 2, the on-orbit, we're not using BFS, except on 104 we do have a GPS DTO, but anyway, that doesn't come in until 79. But so no worry for this one. But we'll take it to halt, and as I say, they'll probably dump it and get all the data they can and figure out what to do with it. But we don't really do anything with BFS on orbit at all. Except beginning next flight when we're trying to do the GPS thing. So that the software is going to be the normal Ops 2 software that we'll be using. Now, what was the other part?
Yeah, let me try to help you out and follow this up. Is this a software or hardware problem, or possibly both? Is it probably pretty minor? And if it turned out to be a hardware problem, do you have a spare GPC you could install, or is that not even something you need to do with 5 aboard anyway?
I think this is a hardware problem, and I think we took our spare GPCs off.
Okay, other questions? Jay?
Before you would get away from that, Lauren, don't you still have a spare GPC under the commander's seat? I remember them changing a couple out, but they've been pulled off.
No, we've had such good luck with GPCs that we're not carrying spares anymore.
And for Jim, how much of a role did USA have to play in this launch, and how much of a role will they have in the next launch?
Let's see, down here at Kennedy Space Center, USA is if I'm not mistaken, I think they have predominantly changed badges. In other words, the majority of the people at USA, if not all of the people. So it was, I guess you could say they played a 50-50 role. Part of the the first part of the flow for the vehicle, it was Lockheed Martin, and then the last half it was USA. And of course for 79, it's probably going to be a little bit more than that because they've already changed over badges.
What do we have, a situation where they've just really changed badges and we still have the same people, the same number of people in the launch team, and maybe a half a dozen or so new integrated in? Is that the situation?
That's essentially the way it is right now.
Okay, thank you.
All right, Seth?
Seth Borenstein, Orlando Sentinel. Lauren, forgive me, I'm still having trouble grasping this here on the BFS. So you don't have any spare GPCs. How many? So that you have redundancies, right? How many GPCs do you need to basically right now? And if you basically say this is just offline because of the problem here?
Well, let's see. You ask a number of questions there. There's 5 GPCs on board. Again, depending on what the data review reveals as to whether what they do with BFS, if they choose to move it, they would put it into a different GPC. And if they still judge this GPC 5 to be usable in the past set, that may be an option. Or if they would rather not use it at all, then that would be an option also. And you would have that same configuration that I described on 32 for entry.
So you can have entry with basically 4 GPCs.
And we've done that before.
And you've done that. If you go down to 3, like you said, you're 1 failure away. What happens? Let's say something goes wrong. You have 3. What does that call for next?
Keep flying.
So there's really nothing that involved here.
You'll do some reconfiguration of data buses on board. Anytime you lose a GPC, you usually end up doing some reconfiguration of data buses at some point. But you can keep flying. Yeah.
Okay.
The machine can be flown on 1 GPC, but
Okay.
of course we don't have any redundancy left then.
And given that you launched precisely on time, does it look like you're going to have the fuel you can go the 17 days? I mean, I know that decision won't be made for another 10 days, but do you see any reason with the launch that you had that you're not going to be able to extend?
I guess I would say as of this moment, I don't see any reason why there wouldn't be prop enough to go the full duration, and the same thing I think on the cryo, but that's a dependency on actual use rate. Yeah.
Okay, one last one for me. I guess this might be for Jim. How you were racing the weather here? Any idea how much ahead you finished? I mean, right now it looks pretty cloudy out there. Do you think you beat it by like an hour, half an hour? How much further would it have been if you couldn't have gone?
I think based on what the weather guys were telling me, I think that we probably would have been pushing our luck to have gone a half hour later.
Okay, let's go to James on the back here.
James Ford from WFTV Channel 9 in Orlando. When we got up this morning, RSS rollback had been, because of that weather last night, had been pushed back 5 hours, and then tanking was back an hour. But lo and behold, when the astronauts were heading out to the pad, they were minutes ahead of time. Can you talk about what your ground crews were able to do to catch back up on the countdown to get us right ahead and then right on schedule?
Well, it was really just a good integrated team effort of pulling everybody together to get the pad clear when we did, and we started, as I said, we started tanking a half hour later than normal. Tanking went just as smooth as silk. There wasn't any problems with respect to tanking, and we were just able to, catch up by the time that the flight crew was ready to come out. And when the ice team went out, they were triggered to go out and jump on it and make their inspections crisp but good, and move out smartly, as was the closeout crew. So everybody was ready and triggered to go work as fast as they could, but yet still do the job correctly, and it just worked out that way.
And for either Lauren or Jim, certainly Columbia has a history of launch delays, but this time this liftoff was right on the money. Has it outlifted its bad reputation?
I think the machine does. If it's ready to go, it's going to go. If there's something that's out of configuration, it'll show up when the time comes to activate that particular system. And you can call it whatever you want, but it's good, solid work on the part of an outstanding launch team. Attention to detail as you're working through all the preparations to go launch that cause you to be able to launch on time.
Okay, thank you. Over here, Bill?
Bill Harwood, CBS for Lauren, I guess. Is there, just to make sure I understand what you're saying earlier, is there no flight rule, or what are the applicable flight rules when you fail a GPC, if it turns out to be failed? Are there any at all?
Oh, yes, there's,
Shorten the flight. I mean, the question everybody's trying to ask is, can you go a 17-day flight if this computer is in fact declared hard failed? I mean, that's the question.
yeah, I don't know of any reason right now, as I say, that we would want to talk about cutting the mission short. You know, I think folks have to figure out what they have in the way of GPCs first before we do any talking about much of anything, even the reconfiguration part of it. But yeah, there's a whole section of DIPS flight rules that deal with GPC failures and the desired stringing for the buses and so forth.
But simply losing one doesn't set up any kind of minimum duration mission kind of rule.
Not one, I don't think, no.
And on FA1, the MDM byte that you talked about, what's the resolution of that? I lost that somewhere.
Well, there's really no resolution. It's something that's going to happen, apparently. It's not a problem with FA1. It's a problem with engine 1 or the center engine, LH2, inlet pressure, transducer, or signal conditioner, or
But it's strictly engine related. It's
path
not related to
between
any
it.
of the other data streams.
Well, it's not even engine related. It's transducer or signal
Okay.
conditioner or path between the two related.
Okay.
Because there was nothing wrong with the engine. It worked fine.
All right, go ahead, Seth.
Seth Bornstein again. Lauren, last few flights you have had a couple hiccups after launch. Is this any kind of trend, or is this just a lot of coincidences in a way, or is this the old aging of the fleet question, or is it just bad luck?
I wouldn't call anything bad luck here so far. There are some things that we continue to learn about our hardware. There's very complicated machinery, so we always see something new and different. Things tend to fail usually in a way that we don't have written down, and so we sometimes come up with new procedures as we go along to deal with whatever we see. But these type of things where transducers go once in a while, or the interpretation of the transducer, of course, that's always been there. But transducers failing, we're all familiar with our water spray boiler behavior over the years, so I don't think there's anything new in that situation. The BFS GPC, again, I don't know if there's anything new in this that we haven't seen before. Whether it has anything to do with how the total runtime on the GPC, it would be way too early to speculate that, because I don't even know what that number is at the moment. How long, what its runtime is in relation to the MTBF.
Okay, Stephen, go ahead.
Stephen Young with Reuters. Is there any extra concern that you've got two problems, one with the GPC and one with the MDM, that might make it difficult to...
No problem with the MDM. No problem with the MDM that I know about now. We originally thought there might be, but it turns out this scenario has been seen before, and there's a note on it that says the MDM did what it did because this deucer went off scale high, and the MDM's just doing its normal thing. It says, I see something unusual I don't understand, here's a byte for you.
Right, okay, well, on a lighter note, it was good to see the pictures from inside the cabin. What do you think the public's going to make of all this, and how do you think the pictures of the launch are going to look? What can we expect to see?
You're referring to the ingress camera. Well, I thought it was interesting. Brought back some memories. You're kind of happy that people get a chance to see that, see what it looks like in the cockpit. It really is fairly cramped in there, as you were able to see. and strapping in is kind of a 2 or 3 or 4 person job. Usually goes better and it's more coordinated if you do that. Also gives you an idea of the relationship of the seating of the crew members. The ascent crew, and by that I mean primarily the commander, pilot, and the MS-2 sitting in between them, with MS-1 sitting off to the side, being able to help out. Kind of gives you that relationship and an idea of how maybe they might begin to train given that setup. On the other hand, there's some thoughts about strap-in time as kind of a private moment, and maybe that's something left to the crew. But whatever, I'm sure that the public will enjoy it and hopefully learn something from it. And the camera shot coming down from ascent, I suspect we'll see some things that show some debris-like substances coming past the window if the resolution, if it catches it. That all could depend on the interplay of the lighting, the sunlight in relation to the pilot's window, and whether there's how much glare is off the window. And after you make the roll program, what changes in the way of lighting, and does that cut off any sight to the outside or not? It'll be interesting what they see. But you'll be looking at a lot of sky, for one, and maybe some white flashes in there of pieces of butcher paper and stuff coming off from the forward RCS.
Do you think it's important that NASA tries to open up more of the shuttle program to the public, and what particular areas that we haven't seen televised so far might be another area you could look at?
Well, I think it'll always be interesting to the public, as I say, to see those portions that they haven't seen before, and hopefully it'll be educational as well, that they'll learn something about what it is we do and what it looks like and feels like, perhaps a little bit anyway from the inside. Let's see, about the only thing left live, and I don't think you're going to get this in the entry tape, would be coming through max heating. The real pink glow around the windows and the sort of the display that you get through the overhead windows. I don't think we'll be in contact yet for that. Everything else, I think we got most of it on film or stills or what, a combination so far.
Okay, thanks. Right here, second row.
Jack Estes, OTV, Orlando. Going into the launch today, you had a fairly liberal launch window of over 2 hours. Could you describe what factors on this mission that placed constraints on the launch window in previous missions were non-existent, or what factors were existent to establish such a liberal launch window today?
Well, let's see. The thing that usually sets the launch mission to start off with is the payload customer and what they're trying to do. And then, of course, we have a series of things that we go through and look at daylight and darkness and when it's daylight at the Cape and so forth. This mission being primarily life and microgravity sciences, there was a good high interest in maintaining circadian shifting or rhythm for the crew, and I think I would say that's one of the primary things that set the beginning of the window where it did, and then the duration is something then that they could work from there. But the duration really turned out to be the 2.5 hour crew on the back time once you strap in.
Okay, we got time for another question. James, why don't you wrap it up?
If we could return for just a second to a question we were just talking about. As I understand it, back in at STS-1, Crippen and John Young were really adamant about not having a camera on the flight deck. What changed in the years since then? What changed to make you all decide that now we can give this a try?
Well, I'm not really sure, other than somebody thought it was a good idea to try to capture the ascent portion and get it on tape and see if there's a way that it shows, see what comes out of it. I I hope you're not disappointed. I don't know. I think I think I think you're going to see a lot of the blue sky, and maybe you'll see some of the motion and vibration and that sort of thing. And I don't know whether it's planned to have any audio with it or not. I wouldn't think that would be on there. Well, I know the camera's not recording it, but
Right.
what you'll see is the video picture out the window, which I don't want to burst anybody's bubble here, but I don't want to raise your expectations. Only to have you sit there and look at that film and say that's a lot of blue sky out there, and it's shaking a lot, because that's.
Do you think this reflects a change among the astronaut corps? I mean, from Young and Crippen saying no way to this crew saying sure, we'll give it a try.
I don't know. I honestly wasn't in on the discussion that led to the use of the camera back in the astronaut office. I think it was a coordinated decision between the astronaut office and PAO and MOD back in Houston.
Okay, well, let's wrap this press conference up, and we'll thank you very much for coming and return to mission programming. Thank you.
Columbia at this point is established in a right-hand bank, and we're showing down here that there are around 65, 66 degrees of bank angle. They of course are holding a constant 40 degrees angle of attack, which is required for thermal control. The flight controls have been active for quite a ways here. They start to operate as a trimmer initially, as a trim surface, when we first start to get a little bit of dynamic pressure, around a half a pound per square foot. And then as we increase the dynamic pressure, as the vehicle gets farther down into the atmosphere, they start to operate in an active mode, and that's where they are now. All of the flight control surfaces, with the exception of the rudder that we don't talk about till we're down around Mach 5, all of the flight control surfaces are functioning to control the flight path and control the attitude of the vehicle at this point.
Columbia is now overhead the southwestern states of the United States, about 2,000 miles away from its touchdown point at the Kennedy Space Center. Time to touchdown now, 20 minutes. All systems on board Columbia continuing to perform well as Commander Tom Hendricks and pilot Kevin Kriegel perform a series of banking maneuvers designed to burn off excess speed as Columbia approaches the landing site.
Columbia at this point is doing what we call processing drag, and what we do is we let the drag get to a certain point, 11 feet per second squared, and at that point what we can do is we can do a calculation that says, okay, we're seeing this much drag, we know what our drag coefficient is on the vehicle, so therefore we can calculate how thick the air must be at that point. We have been calculating all along what our altitude was. This is the first opportunity that we have to take that calculated altitude and compare it to a drag reading